The shipyard is quiet in the hour before dawn, but it's not empty. Dock workers move between floodlights, checking valve wheels and tow lines. A brand new commercial fishing vessel sits in a concrete basin, still dry, its steel hull gleaming under the lights. The air smells like salt, diesel, and fresh paint. In 90 minutes, seawater will flood this dock, and the boat will either float free or reveal every mistake made in the last 18 months of construction. This is not a recreational boat being backed off a trailer. Commercial fishing vessels, steel-hulled trawlers, longliners, crabbers, are launched using dry docks or marine railways, and the process is timed down to the minute. The shipyard has a narrow window, usually between 90 and 120 minutes, when the tide is high enough to flood the dock, but not so high that it rushes in too fast. Weather matters too. Wind above 15 knots can push the vessel against the dock walls before it floats free. Rain delays inspections. Fog grounds the harbor pilot. Every launch requires coordination between the shipyard crew, the vessel owner, a marine surveyor, and often a Coast Guard inspector. The hull must be structurally ready. Ballast tanks must be calculated and loaded. Hatches must be sealed. If any one element is off, the launch gets pushed back 24 hours or more and the tide window closes. Most people think ships are just pushed into the water. They're not. Modern launches are controlled flooding events. Valves open, water rises, the vessel lifts off its blocks. And if the timing is wrong, the consequences show up fast. The most common method for launching a steel commercial fishing vessel is dry dock flooding. The vessel is built or positioned inside a sealed concrete basin. Underneath the hull, wooden or steel blocks hold it level and stable. These blocks are carefully placed according to the naval architect's drawings, supporting the keel and frame at reinforced points. Once the vessel is ready, the shipyard opens intake valves at the base of the dock. Seawater flows in, controlled and steady. The flooding takes 60 to 90 minutes depending on dock size and valve capacity. Workers monitor the water level and watch the hull for any shift or tilt. As the water rises past the blocks, the vessel begins to float. When it lifts free, tugboats or dockhands guide it away from the walls using lines. The blocks stay behind on the dock floor. This method is used across major fishing vessel builders in the Pacific Northwest, the North Atlantic, and Northern Europe. It allows for precise control and minimizes stress on the hull. The vessel enters the water evenly, and any imbalance shows up immediately while the dock crew is still on site. The second method is the side launch, or slipway. This is older and still used for smaller fishing boats, especially in traditional shipyards. The vessel is built on a sloped ramp that leads directly into the water. It sits on a cradle or greased rails. When the time comes, the cradle is released and the boat slides sideways or stern first into the water. Gravity does the work. The launch happens in seconds, not minutes. It's dramatic and requires exact calculations. If the angle is wrong or the cradle sticks, the vessel can hit the water too hard or roll. Side launches are less common now for large commercial vessels because the risk is higher and the margin for error is smaller. The third method is the hydraulic lift, or synchrolift. This is the most modern and most expensive. The vessel is built on a platform that can be raised or lowered by synchronized hydraulic lifts. The platform descends into the water, the vessel floats off, and the platform is raised back up. Synchrolifts are used in shipyards that handle multiple launches or need to move vessels in and out of the water, frequently for maintenance. They offer the most control but require significant infrastructure investment. Not every fishing port has one. If the timing or setup is wrong during any of these methods, the results are immediate. A vessel that lists more than a couple of degrees during a dry dock launch may have uneven ballast or a miscalculated center of gravity. Water can pour through an unsealed hatch or an open through-hull fitting. Hull plating can scrape or dent against dock walls if the vessel shifts before it floats free. In a side launch, too much speed or the wrong angle can cause the hull to slap the water and crack welds or frames. These are not minor cosmetic issues. They are structural failures that require the vessel to be pulled out, repaired, and relaunched days or weeks later. The launch method depends on three things: the size of the vessel, the infrastructure available at the shipyard, and the local tidal range. A 70-foot trawler built in a small coastal yard might go down a slipway. A 120-foot longliner built in a commercial shipyard will almost certainly use a dry dock. Synchrolifts are reserved for high-volume yards or military contracts. The method also affects hull integrity. A controlled dry dock flooding applies water pressure gradually and evenly. A slipway launch is faster but puts sudden stress on the hull structure. The first contact with water is the first real test of whether the welds, frames, and plating can handle the forces they were designed for. Cost varies widely. Dry dock launches typically cost between $15,000 and $50,000 depending on vessel size, dock rental time, and labor. That includes dock fees, water pumping, tug services, and crew. Slipway launches are cheaper but riskier. Synchrolift launches can run higher due to equipment and operator costs. These are expenses the vessel owner pays on top of the build cost, and they come at a point when most of the vessel price has already been paid. There is no fishing, no revenue, and no way to recover the investment until the boat is in the water and working. 2 days before the scheduled launch, the shipyard shifts into inspection mode. Welders return to the hull with grinders and magnifying glasses, walking every seam from bow to stern. They're looking for hairline cracks, incomplete welds, or any sign that the steel didn't fuse correctly. Even a pinhole leak below the waterline can sink a boat. If the vessel is already sitting partially afloat in a flooded dock, divers go down with underwater lights and run their hands along the hull plating, feeling for gaps or rough edges that didn't show up on the surface. At the same time, engineers are recalculating the vessel's center of gravity. They measure the weight of every installed system, engine, fuel tanks, refrigeration units, winches, net drums, and compare it to the original design specs. Then they load the ballast tanks with water to simulate the weight of fuel, ice, and fishing gear the boat will carry once it's working. The goal is to make sure the vessel will float level and stable, not bow heavy or listing to one side. If the calculations are off, ballast has to be redistributed or additional weight added before the launch can proceed. Hatch and valve sealing comes next. A commercial fishing vessel has between 20 and 40 through-hull fittings. These are openings in the hull for engine cooling water, bilge discharge, live well intake, and deck drains. Every single one has to be sealed, tested, and verified. Deck hatches are dogged down and checked for gasket integrity. Engine room vents are inspected. Even the shaft where the propeller connects to the engine has a seal that can fail if it wasn't installed correctly. The pre-launch checklist runs to several pages. Bilge pumps are tested under load. Emergency lighting is switched on. Tow lines are rigged at bow and stern. Fire suppression systems are armed. The owner is often on site during this phase, walking the deck with the shipyard foreman and the naval architect. There's tension in the air because everyone knows what's at stake. Many launches get delayed. Weather is the most common reason. A forecast calling for wind or heavy rain can push the launch back 24 to 72 hours. Paperwork delays happen too. Missing Coast Guard certifications, insurance sign-offs, or final payment disputes between owner and builder. Failed leak tests are another cause. If a through-hull fitting weeps water during pressure testing, the launch stops until it's fixed. There is no margin for maybe. When the vessel finally lifts off the blocks, there's no cheering. The shipyard crew and the owner are watching the waterline. The hull should sit exactly where the naval architect predicted, with the boot stripe, the painted line that marks the designed waterline, parallel to the surface. If the bow is riding high or the stern is sitting low, something is wrong with the weight distribution. If the vessel lists to port or starboard by more than a degree or two, the ballast is uneven or there's water where it shouldn't be. The first visual check happens within minutes. Crew members walk the deck and lean over the rails, comparing what they see to the drawings. They're looking for anything unexpected. Water lapping higher than it should, the hull sitting deeper on one side, or any sign that the vessel is taking on water faster than the bilge pumps can handle. Because every boat takes on some water. Seams flex, fittings settle. The bilge pumps are designed for this. What matters is the rate. A few gallons per hour is normal. A few gallons per minute means there's a leak. Shipyard workers and the vessel's crew monitor the bilge pump cycle using a timer and a sight glass or electronic sensor. If the pump is running every 10 minutes instead of every hour, they start tracing the source. Is it coming from a through-hull fitting, a cooling waterline, a hull seam that didn't seal under pressure? If the engine is installed and operational, this is when it gets started for the first time in the water. The cooling water intakes open, seawater flows through the heat exchanger, the exhaust exits below the waterline or through the transom, and the crew checks for proper flow and temperature. An engine that overheats during the first start usually means a blocked intake or an airlock in the cooling system. Both are fixable, but they ground the vessel until they are resolved. This 2-hour window is the one bottleneck that determines whether the launch succeeds or fails. The vessel's floating characteristics either match the calculations or they don't. The hull either holds water out or it doesn't. There's no faking it. If the bilge pumps run continuously, if the list exceeds 2 degrees, or if any critical system fails, the vessel gets towed back to the dock or pulled out of the water entirely. That means days or weeks of delays, tens of thousands of dollars in additional dock fees and labor, and owner who has already paid 80 to 90% of the vessel's cost but can't fish, can't generate revenue, and may be facing penalty clauses in the build contract. This is the first real-world test of hull integrity and stability. Everything before this was theory, math, and dry land inspection. Now the ocean is applying pressure to every weld, every fitting, and every design decision. The bilge water accumulation rate in these first 2 hours is the most critical metric. It tells the truth. A successful float test doesn't mean the vessel is ready to fish. Within 24 to 48 hours of launch, the boat is either towed or motors under its own power to open water for sea trials. These trials typically last 1 to 3 days and take place in conditions that simulate actual working environments: open ocean, moderate swell, and full operational load. The shipyard sends a crew. The owner or owner's representative is usually aboard. A marine surveyor documents everything. If the vessel is being financed, the bank's inspector may be there too. The trials follow a checklist that starts with basic handling and builds toward full operational stress. First comes the full speed run. The engine is pushed to maximum RPM and held there for 30 to 60 minutes. The crew monitors engine temperature, oil pressure, fuel consumption, and exhaust color. They're listening for vibration, knocking, or any sound that suggests a problem. The hull is watched for flexing or unusual movement. Speed is recorded and compared to the design specification. A vessel that can't hit its rated speed either has a fouled propeller, a misaligned shaft, or an underpowered engine. Next is the turning radius test. The helm is put hard over, and the vessel is run through a full circle at various speeds. This reveals how the boat handles under load and whether the rudder and steering system respond correctly. Emergency stop tests follow. The engine is thrown into reverse at speed, and the crew measures how long it takes to come to a full stop. This matters in crowded harbors, around other vessels, and in fishing grounds where nets and gear are deployed close to the surface. Then the working systems get tested. Winches are spooled out and retracted under load. Net drums are deployed and retrieved. Hydraulic systems are cycled repeatedly to check for leaks, pressure loss, or overheating. If the vessel has a refrigerated fish hold, it's powered up and brought down to temperature while the boat is underway. The refrigeration system has to work while the engine is running. The boat is moving, and the electrical load is at its peak. On land, these systems were tested individually. At sea, they all run at once. This is when problems show up that couldn't be predicted on the dock. Engines overheat because the cooling water intake is positioned wrong and cavitates in certain sea states. Hulls vibrate at specific RPM ranges due to propeller imbalance or shaft misalignment. Hydraulic lines crack under sustained pressure. Electrical panels trip because the load calculation didn't account for all systems running simultaneously. These aren't design flaws necessarily. They're real-world interactions that only appear under working conditions. Some vessels return to the shipyard 2 or 3 times for adjustments after launch. A persistent vibration might require the propeller to be pulled and rebalanced. An overheating engine might need the intake repositioned or the heat exchanger cleaned. Hydraulic leaks get traced and repaired. Each return costs time and money, but it's better than delivering a boat that breaks down on its first fishing trip 200 miles offshore. Sea trials are not optional. Insurers require them before issuing a policy. The Coast Guard or equivalent maritime authority often requires a signed sea trial report before issuing a commercial fishing license. Without that documentation, the vessel legally cannot work. The trials prove the boat can handle real-world conditions: wave action, sustained engine load, and full operational use, not just calm water and idle speed. The owner does not take full possession until the sea trials are complete and signed off by the surveyor. Until that moment, the vessel technically still belongs to the shipyard, and any failure is the builder's responsibility. And once the trials pass and the documents are signed, the risk transfers. The owner takes the helm and the shipyard's liability ends. A fishing vessel that misses its launch window doesn't just sit idle at the dock. It misses the season. Salmon runs in Alaska peak in June and July. Dungeness crab season on the west coast opens in November. King crab in the Bering Sea has fixed opening dates set by federal quota. If a boat isn't in the water, certified, and ready to fish when the season opens, the owner loses weeks or months of revenue that can't be recovered. A missed crab opener can cost a vessel owner $200,000 or more in lost catch value. The financing doesn't pause. Loan payments continue whether the boat is fishing or sitting in a shipyard, waiting for repairs after a failed launch. Most commercial fishing vessels are financed through marine lenders who structure loans around delivery dates and projected earnings. The payment schedule assumes the boat will be working by a certain date, generating income to cover monthly installments. A launch delay of even 2 weeks can trigger penalty interest, covenant violations, or require the owner to inject additional cash to stay current. The bank isn't financing a hull, it's financing a business, and that business has to produce. The launch is the moment when years of planning, design, regulatory approval, and investment turn into a working asset. Owners often spend 18 months to 3 years from initial design to delivery. They've chosen the hull shape, the engine package, the deck layout, the refrigeration capacity. They've navigated Coast Guard inspections, environmental permits, and fishery license transfers. They've made dozens of decisions that will define how the boat fishes, how much it can carry, and whether it can operate profitably in their target fishery. All of that comes down to whether the vessel floats correctly and passes its trials. Some owners treat the launch as a ceremony. They bring family. A bottle of champagne gets broken against the bow. There are photos, handshakes, and sometimes a blessing from a local priest or elder. It's a tradition that goes back centuries, and it still happens even on modern steel trawlers built with CAD software and CNC cut frames. But underneath the ceremony is a high-stakes engineering test. The owner is watching the waterline just as closely as the shipyard crew. They know what's riding on the next 2 hours. If you ever buy a commercial fishing vessel, ask for the launch documentation, the float test report, and the full sea trial results. These documents reveal build quality in a way that a survey or a haul-out can't. A clean launch with no delays, no list. And minimal bilge water means the builder got the details right. Sea trial results that show the vessel hit its speed, handled correctly, and had no system failures predict fewer breakdowns and a longer working life. Resale value is directly tied to this history. Buyers pay more for boats with clean records and documented trials. They avoid boats with launch problems, repeated repairs, or missing paperwork. A vessel that launches clean and works reliably from day one isn't lucky. It's the result of precision at every stage: design, construction, inspection, and launch. That precision pays off in uptime, safety, and profit for the next 20 to 30 years. If this is changing how you see the fishing industry, hit like and subscribe. Comment below, have you ever seen a ship launch in person, or would you want to? Now here's what happens when something goes wrong during sea trials. Launching a commercial fishing vessel is not a moment. It's a process that spans days, involves dozens of people, and tests every decision made during construction. The preparation begins 48 hours before the water touches the hull. Welders inspect seams, engineers calculate ballast. Every through-hull fitting gets sealed and verified. Then comes the controlled flooding or the slipway release, timed to the tide and the weather. The vessel floats free, and the bilge pumps tell the first truth. The float test reveals whether the hull holds and whether the boat sits where the drawing said it would. Sea trials come next, pushing the engine, the systems, and the structure under real-world load. Only after all of that does the owner take possession. This is not a simple push into the water. It's a high-stakes engineering event that determines whether a multi-million-dollar investment works or fails. The launch is the moment when theory meets ocean and there's no room for error. The next time you see a commercial fishing boat tied up at the dock or working offshore, remember it survived its most dangerous day before it ever caught a fish. The people who built it, launched it, and tested it earned that boat's first mile. Subscribe for more. Subscribe for more.